If you've ever been handed a project brief, you know the feeling. You're staring at a massive wall of text, dozens of pages describing what a system should do, packed with jargon and competing ideas. To build functioning software, you have to translate that fuzzy language into a precise visual blueprint. We do this using a method called structured analysis. This process results in two specific deliverables: data flow diagrams, which map how information moves, and a data dictionary, which catalogs every single piece of that information. By mapping out exactly where data originates, where it goes, and how it transforms, you guarantee that everyone on your team understands the system's mechanics before a single line of code is written. Step 1 is defining the system boundary with a level 0 context diagram. A single circle represents our software system, the safe home system. Surrounding it are external entities: the user, sensors, and alarm. We treat the central system as a black box, ignoring its internals. Our concern is identifying data flowing in and out. Notice that we are only tracking data objects. There is absolutely no control logic here. You will not find if-then decision pathways or sequential loops in this diagram. By stripping away the internal mechanics, this level 0 diagram acts as your anchor. It ensures you capture every external input and output before you get bogged down in the complex details. Now we need to figure out what actually goes inside that black box. To do that, we look directly at the original requirements document and apply a technique called the grammatical parse. We read through the narrative and isolate the action verbs, words like monitor, configure, or dial. These verbs represent the core processing functions your software will perform. Next, we scan that same text for nouns, phrases like sensor data, password, or alarm signal. These nouns identify the specific data objects that will move between those processing functions. This simple grammar exercise removes the guesswork. It takes a client's vague language and converts it into a strict, objective list of parts for your engineering architecture. With those parts identified, we crack open the level 0 black box to create our level 1 diagram. The single system circle separates into smaller process bubbles, each labeled with one of the verbs we just found. Then we use our extracted nouns to draw the data arrows connecting these distinct processes. Now we have a web showing how information actually travels through the system. As we build this out, we have to enforce a strict rule known as information flow continuity. Think of it like a balance scale. Every single input and output arrow on the outside of your level 0 diagram must perfectly match the outer edges of this new level 1 diagram. We visually audit the diagram by checking them one by one. If an alarm signal leaves at level 0, it has to exit the system here at level 1. When inputs or outputs magically appear or disappear, you lose continuity. That disconnect is exactly how development teams end up with missing features and failed integrations later on. Even at level 1, some of these process bubbles are going to be too dense. A function like monitor sensors might contain too many hidden actions to easily hand off to a programmer. When a process is too complex, we use a technique called hierarchical refinement. We zoom in on that single bubble and expand its internal space. Inside this new level 2 diagram, we split that dense process into single-minded subprocesses, like read sensors and generate alarm. And again, we ensure the data flowing into and out of this micro-level perfectly matches the parent bubble above it. This iterative drill-down method lets you manage highly complex systems. You never have to solve the whole machine at once. You just focus on one isolated puzzle at a time. As these diagrams scale down to level 2 and beyond, you will generate dozens of bubbles and arrows. Keeping track of them entirely by memory quickly becomes impossible. This is a data dictionary. It serves as the single source of truth for your entire system model. Every data object gets logged here. For an object like sensor status, you document its exact definition, the process where it originates, and the destination process that receives it. If one developer calls it sensor status and another calls it sensor data, the dictionary flags the conflict. This ensures your team doesn't accidentally build two different features for the exact same piece of information. The data flow diagrams provide the map, but the data dictionary provides the unbreakable legend that keeps a large development team perfectly aligned. We've taken a messy, dense narrative and converted it into a highly structured, multi-tiered data model. Because of this structure, a developer has full traceability. They can track a single piece of data from the 10,000-foot view all the way down to a granular, single-minded component. With the flow of information verified, the next step in the engineering process is mapping this 2D model into a physical, executable software architecture. So stop staring at walls of text. Open up your diagramming tool, find your action verbs, and start mapping out your data flow today.